Hello friends, welcome to video number 22 or question number 22 in which we are going to discuss foursome. Before that, let me introduce you about the link which will be flashing below, which is the link for you to join the practice group. Okay, in this practice group, I post questions on data structures and algorithms in which the participants have around maybe say 24 hours to try it by themselves. They can ask me any doubts or if they're getting stuck anywhere and ask me how to move forward. I help them, and after 24 hours they can watch the solution just like this video and learn how they can solve the problems. In the videos I am also sharing a lot of insights about interview cracking, about tips and tricks, about problem solving, about the basics which one must master before being capable of learning data structures and algorithms, right? And why, what gives me the authority to do so? Let me introduce about myself. My name is Akshaya. I am from IIT Delhi, BTech Computer Science graduate. I have worked at companies like Amazon and Paytm as software engineer, senior software engineer, and also have trained students who, with the help of my training, were able to crack companies like Microsoft, Paytm, and are working there with handsome packages. Okay, so you must click on the link and join this practice group as soon as you can. Okay, now let's come back to the problem of foursome. Before we discuss this problem, let me introduce you some very special thing about the video. I'm going to, as I said, I'm going to introduce a lot of tips and tricks, a lot of insights, right? So please make sure you watch the video till the end. Don't skip anything because I'm going to embed a lot of tips inside this and you never know which tip is going to work in the future. Second, the problem is not very interesting from the point of view of interview cracking, but it's going to share a lot of insights because it is going to help you expand your mind. When I say it is not so much important from the point of view of interview cracking, I mean to say is that probably the interviewer may not ask you this question, okay, directly, but they might like to discuss with you, okay. And I'm also give the solution which I'm going to give, I'm giving you with the perspective of helping you open your mind because I am going to introduce new ways of doing this problem. Okay, basically not just this problem but any other problem, because I'm going to introduce certain kind of design patterns or a completely different way of solving this, like probably which you have may not have thought before. Okay, so let's dive deep into this. Don't forget the link, click and join. Great. Given an array nums of n integers and an integer target, are there elements a, b, c and d in the nums such that a plus b plus c plus d is equal to target? Okay, I know that probably most of you would have already tried a question which is like twosome, right? Where you have to find two numbers in a given array whose sum is equal to target and you have to return them. Okay, probably you may be asked to return whether there exist two numbers, such two numbers or not, right? Probably just a boolean, right? Or maybe just return one unique solution, right? Maybe even return multiple solutions, all multiple solutions possible, but probably you would not have come across a problem with foursome, right? Where where you have to find four numbers whose sum is equal to target. And not just that, you have to find all unique quadruplets in the array which give the sum of target. Now this problem is pretty simple if you have done that twosome problem, right? If you apply the worst case algorithm also in this problem, the site is going to approve it and you will get all test case passed. There won't be any time limit exceeded for that, right? But the only thing that probably you might be missing on your end is how do you apply the same approach in this, right? So there are multiple solutions possible. The approach which I am going to give you right now you wouldn't have done. Okay, the algorithm is pretty much easy. The algorithm I'm again saying is pretty much easy, but how am I going to apply this algorithm? You will see the genius of the solution in that, and probably it will give the light, put in the seed inside your mind to maybe solve 100 more questions like this. You will be able to appreciate the beauty of the solution and apply to further data structure and algorithm problems. Okay, the solution set must not contain duplicate quadruplets. I will introduce and give two solutions with code, and probably I will share another solution with you without the code and let you do it by yourself. So keep watching the video towards the end entirely. Okay, so let me just do this with the help of showing you a diagram. Okay, let me show this problem with the help of a diagram. So basically you have to find four numbers, right? You have to find four numbers. Probably I don't even need to draw. Okay, so basically you have to find four numbers in the array whose sum is equal to a given number, right? So what's the worst case scenario? What's the brute force method for this? The brute force method for this is going to be that you have to pick all pairs of four numbers from the array and see whether their sum is equal to the given target. If it is, great, right? You have found them and add that to the answer. Or if there is not, you just simply move to the next pair and see, right? So let me just write down a pseudo code for this and explain to you what I'm trying to say, though I'm pretty sure that you already understood what I meant. Okay, so the code will be find all pairs of four numbers. For each pair, check if their sum is target. If it is, add these pair to the solution list and keep checking for duplicates. Okay, so this is a pretty simple algorithm and this is my first solution which I'm going to implement it. But the way I'm going to implement is going to introduce you to multiple concepts. One is about the design principle and the second thing is going to introduce you is about the equals concept in Java. Okay, this can be extended to other programming languages also, and also creating a new class while trying to solve a problem. Completely new data structure, right? See, the interviews of data structure and algorithm is not just about your ability to solve the problems by using the existing data structures. It's mainly about your ability to apply different data structures to a given problem. When you will be in the interview, the interviewer won't tell you always that which data structure they are expecting you. They are going to test your ability to go into your own mind and think of which data structure you're going to apply and how optimized the code is as per your knowledge. And if there's some other data structure which could have been applied, then apply that, right? So they're expecting you to be able to work with different data structures, create new data structures according to the problem and choose the best one, right? So here I'm going to create new data structures and you're going to learn that very new method. Okay, so find all pairs of four numbers, right? Okay, so what is the time complexity of this algorithm? The time complexity of this algorithm is going to order n to the power 4, right? Because how many pairs of numbers are going to be which have four numbers? You have to basically do nc4, because of which four terms will get multiplied, right? N by 4 into n minus 1 by 3 and so on, right? Or you can even say like this: each number is going to be paired with the rest of the n minus 1, and the pair of these two numbers is going to be paired with the rest of n minus 2 numbers, and these three are going to be paired with n minus 3. As a result, when you multiply all of them, you get around n to the power 4 pairs, right? And you are checking for each of them whether the sum is same or not, right? And you're also checking for duplicates, right? You're checking for duplicates. So because you are checking for duplicates, let's say the current list of solutions has m solutions, right? And you got another pair. Now you will have to compare this pair with probably each of the numbers in the solution, because of which your complexity will have an additional order m, right? Or if you're using a hash map, it will be probably order 1, right? But even then it won't exceed the number n to the power 4, and as a result this is going to supersede and the time complexity will remain order n4. But here comes the tricky part. Okay, if you would have done the two-sum problem using hash maps, right? Using hash maps, how did you do that? When you applied the problem in hash maps, you basically took a single number, right? You basically took all the numbers and you put that in a hash map. Now you traverse the existing array, right? You pick up the number x, you find out what is target minus x, let that be y, and then you check whether your hash set or the hash map has a number y in it. If it is, you have found a pair and you return the answer, right? But here comes the difficult part in this one. How do you do it for when the numbers are like 4 in number, right? How do you do that? Because if you have a given one number, how do you know what do you have to find, right? So let me show you the solution also, how we can work on this. Okay, how do you actually match whether the given number is present or not? Okay, so ignore the part of the code which I am not explaining to you right now. Just focus on the part that I am explaining. Okay, so this part we all know. We can see 4 loops are going over here, right? 4 nested loops are going over here. This is the loop for finding the first number of the pair, the second number, right? I equal to 0 to length minus 3. So this is going to be the first number of the pair. The second number will begin from index I plus 1 to length minus 2, third one from j plus 1, and the fourth one from k plus 1, right? So in this way we will be able to find all 4 pairs and we are going to sum them, and we are going to see if their sum is equal to target. If their sum is equal to target, we can actually save that number in a set, right? You can just assume it's a simple set and see whether that set already contains these 4 pairs of number or not. If it contains, then we will ignore this pair, but if it doesn't contain, then we can add them, right? As simple as that. And then eventually we will return this set of numbers, set of pairs, and we will be done. It's very simple. So before I move on to the complicated part, let me just dive further deep down into this about the limits, right? So the first number index begins from 0 and it goes to num's length minus 3. Okay, why num's length minus 3? Let's say if we didn't have to find 4 numbers, let's say we had to find only one number which is equal to target, then we would have gone from I equal to 0 to I less than nums dot length. That's enough, right? Because then I will go from 0 to last index, right? Because it's less than nums dot length. But let's say we needed 2 numbers, right? So because of that, we would have to leave space for one more number towards the end, right? Because let's say if I went from 0 to nums dot length minus 1, right? Even the last index would have been covered, right? So you cannot find any other number other than 0 to n minus 1. That's why you will have to leave at least one space behind, so that if I becomes equal to the last index possible, there is space for jth number, because j will always begin from I plus 1, right? Let's say there are 5 numbers and our I is equal to 0, then j can be from 1 to 4 index, right? If I is equal to 1, j can be from 2 to 4. If I is equal to let's say 2, j can be from 3 to 4. If I is equal to 3, j can be only 4. But if I becomes equal to let's say 4, and we have only 5 numbers, right? So index 4 represents the last number, and as a result of which j will become 5, but that index doesn't exist, right? Because of that logic, you will see that we have nums length minus 3, nums length minus 2, nums length minus 1, right? And up till nums length. Okay, that is the easy part. Now let's jump into the difficult part. The question says that there should not be any kind of duplicate quadruplets, right? There should not be any kind of duplicate quadruplets. You can read the question again if you want to see it, right? Now the problem is, how do you find whether numbers are duplicate or not? Okay, a very simple strategy for that is, you can sort all the numbers in increasing order, all the 4 numbers, and whenever a new number comes in, new pair of number comes in, you match them and you return, right? That's pretty cool. But the problem is, we don't know what position they are stored, right? So let me just draw and show that to you what I mean. Let's say we got 4 pairs of numbers like this. Okay, this is number 1, this is number 2 stored over here, and number 3 and number 4, right? 1, 2, 3 and 4, right? Let's say this was pair 1 and we have even sorted, right? Now let's say we got another unique pair 2. We got another unique pair 2, okay, which is also sorted, so that it becomes easy to compare, right? Similarly, let's say we have pair 3, right, pair 4, pair 5, and so on and so forth. So let's say a new pair comes in, right? Let's say this pair is X, right? So how do we compare this pair is present in this list or not? One way of doing that is you take this pair, match with the first pair, right? Then you match with the second pair, then you match with the third pair, match with the fourth pair, match with the fifth pair, and so on and so forth. You will be able to find, right? But what if I give you an easier way to do that, actually a more beautiful way of doing that? And let's say instead of storing that in the list, you wanted to store in a hash map or a hash set, so that you don't have to compare with each and you can directly go in unit 1 time and see whether the given pair exists in the hash set or not. Okay, but there is a slight problem. The problem is, how does a hash set work or a hash map work? A hash map works by using the method called as contains. Okay, basically the hash set has a method called contains, which checks whether the given element is already present in the hash set. Okay, and how does that contains function work? The contains function basically knows how to compare pairs, how to compare the two elements. But right now we don't have any method how one set of four numbers can be compared with another set of four numbers. You would say it's pretty easy, right? Four numbers are there, another four numbers are there, you just compare them. But there's no way right now to tell the compiler that we want the four numbers to be compared in this way, right? Because what is if you don't define your own way of comparing, what your method of contains in hash set is going to do is it's basically going to see, let's say the numbers stored in X are 1, 2, 3 and 4, right? So it would be probably stored in some memory. Let's say that memory location is A. Okay, that memory location is A. Similarly, this one also, let's say, has a value of 1, 2, 3 and 4. Now this one won't be stored at memory location A, but at some other memory location B. Okay, and now you are going to call an equals function on these two. These will be returned as unequal. The reason being, these two are actually stored at different memory locations, as a result of which they will be, when your code is going to call equals method or contains method, this will come as false, and as a result this duplicate will be added. Okay, because of this your hash set method becomes useless in this scenario, right? But the hash set method can be of great use in a lot of problems, but only because of this shortcoming we are not able to use it. So what if I give you that method, give you that technology which can help you use the hash set even on complex problems, complex information like this, right? Remember, I told you in the beginning of the video that the interviewer is trying to test your ability to create data structures that suit your needs. So I'm going to create a data structure, and I'm going to create a way such that the contains method in the hash set will work even on complicated information like this data structure, right? So we are going to learn two things. One thing is about how do we represent these four numbers in a data structure. Why are we doing that? So that we are able to call the q set, the hash set contains method on that, right? Secondly, we are also doing that because we want the numbers to be compared in a certain way, right? For example, let's say if the numbers were not sorted, they were not 1 2 3 4 and 1 2 3 4 like this. If they were in different order, let's say in this one the order was something like 3 1, right, 4 and 2, the order is important, right? And because of this is still not same as this, right? So we want them to be sorted or be compared in a certain fashion. So I'm going to show you how you can compare two actually different objects, right? This is a different object, this is a different objects, and return an equal result as per your choice, right? We want in our universe of the code, we want 1 2 3 4 be equal to 3 1 4 2. What we basically want is, if the four different pairs in whatever order are same as four different numbers in whatever order, they should be same. So we are going to learn next how we can do that, right? And there will be small additional tips which I am going to give you. Okay, so one thing is very simple. If you want to say four numbers, you have to create a new data structure for that, and you can probably call that a quadruplet, right? You can probably call that a quadruplet, and that's what I did. Okay, so let's just focus upon the things which I'm sharing. So I created a class called quadruplet, and obviously it will have four numbers. And then I created a constructor method in this, in which four input numbers are being presented, right? And I hope so when you're watching this video, you do understand that there are so many more things that I have to teach you, and so many things I myself also have to learn, because while making this video I realize, why not bring in this method, right? So always stay humble and always keep learning, and go dive deep into the rabbit hole, right? Don't stick on the surface. Don't think you already know all the answers. Keep learning, even see the small problems, small answers with attention to detail, with a great eye for detail, right? And keep learning, because if you already knew everything, you wouldn't really be right here where you are, especially when it has been a long period of time when you are there, right? So always keep learning, always keep moving level ahead, keep pushing yourself. Okay, okay, so in quadruplet is that data structure which has four numbers inside that, right? And a simple method would have been that I assign these quadruplets uh, members a b c d equal to that, right? I could have just written this dot a is equal to a, this dot b is equal to b, this dot c is equal to c, this dot d equal to d, and I would have been done, right? But what I actually did is, I assigned these numbers into an array, and simply with the help of arrays.sort, I was able to sort these numbers in an increasing order, right? That's the best way of comparing two things, that always keep them sorted so that the small parts of them can be compared correspondingly, right? Because otherwise, if you keep them not sorted, then it becomes very difficult to match the pairs, right? So that's why I sorted them, and then I assigned this dot a equal to num0, this dot b equal to nums1, this dot c equal to nums2, and this dot d equal to nums3. So till now it's pretty easy. Okay, but let me just introduce a small complication. Because of the sorting over here, the actual order between these number a b c and d which they occur in the array changes, right? For example, let's say this number was 4, this was 5, let's say this was 9, this was 8, this was 7, and this was 6. Okay, and our question was expecting that order to be maintained, right? It wanted that order to be maintained, right? If the numbers have come in the order of 9876, it wanted them to be 9876, but here it may probably get sorted in the reverse order and become 6789, depending upon how the arrays dot sort work, whether it sorts them in increasing order or decreasing order. So because of that, the order will be changed, and when you will return these pair of numbers, these four pair of numbers, the pair of four numbers, your answer will be rejected. So in that case, the solution would have been that instead of changing this dot a, this dot b, this dot c, this dot d as the sorted numbers, what you could have done is, you could have stored that information 2 times. Okay, what I'm saying is basically you would have stored this dot a as a, this dot b as b, this dot c as c, this dot d as d, so that at the time of returning the answer, you can simply return a comma b comma c comma d, right? And you could have maintained an array which is sorted. So you would have maintained this information 2 times. One is you would have maintained the order a b c d as it is, and then you would have kept a sorted array, right, which will be used for comparison with another quadruplet. Okay, so the sorted array will be used for comparison with another quadruplet, and while returning the value, you would have used a comma b comma c comma d in the same order as it was passed in the input. Okay, so here I have basically given you two kinds of design patterns or two ways of thinking the same problem, and you can think of many more design patterns just from this of how to solve it. Okay, there are going to be so many design patterns which are out there which can help you do problems. So what is basically a design pattern? A design pattern is basically a template or a form of thinking or a form of solving the problems in a certain fashion, and on the fly you can create many more. Okay, obviously there are some popular ones, right? So interviewers are not exactly going to ask you to solve the problem using one design principle, but they would be expecting you to create new design principles or be able to choose whatever design principle you have in mind, but it should be able to solve the problem and should be able to show that you are capable of doing an independent thinking. Okay, so coming back, so till now what we have done is we have created a new data structure which can store that information in a sorted fashion, and we also know if the original order was important, what we would do, we would maintain the sorted information as well as the original order. Okay, now comes the interesting part. Okay, this is the most crucial part probably of the video if you have understood all the other concepts. Now this method is equals. Okay, and why is this important? Remember the hash set contains method. The contains method, what does it do internally, right? This question is going to force you to think, how does Java or any other programming language work on any function? So how does the contains function actually work? The contains function is probably going to take your object which you are inputting, and using the hash algorithm, it's going to compare the existing object with this. And how is it going to do the comparison, right? Each object in Java, each class in Java inherits from the object, and that object class has a method equals. This equals method tells whether the given object is equal to the object which is being passed as input, right? And if you don't define your own equals method, what it's going to do is it is probably going to use the hash code which is present, which is generally linked to the memory where it is stored. If the two memories are going to be different, then the answer is going to come wrong. That's why it is very important that you define your own equals method, right? And now it becomes very simple because we have already sorted the numbers. What we are going to do is we are going to just compare the four numbers correspondingly, that is a equal to other dot a, b equal to other dot b, c equal to other dot c, and d equal to other dot d. If and only if all these four numbers in the current quadruplet as well as the other quadruplet are same, then we know these two are same, otherwise not, and we can simply return equal, right? We can simply return this variable. Okay, and we will be done. Now what is this quadruplet O equal to quadruplet other? This is basically, you can say, a needed syntax in Java to be able to convert the given object into the object of the current class. Okay, and now what is this code? This code is basically simply I use to test whether my code is working as per I ask it to, and whether the equals method is getting called or not. I am sharing this method because probably you are going to need this to test whether your code is working, because if you have followed till now, even with this, your equals method will give you a wrong answer. Okay, and let me explain why. Now the equals method doesn't work in isolation. It also needs a hash code. It also needs a hash code. So if let's say this object has a hash code value 5 and your this class object has a hash code value of maybe 1. Now because 1 is not equal to 5, the equals method will still give you a wrong answer. Both the objects must have the same hash code. Until and unless they will have the same hash code, it is not possible for the equals to work correct, right? So I could have returned a hash code on the basis of what numbers are present. Like for example, I could have simply added A with B with C with D and written over here, right? So whenever two pairs of 4 numbers which have the same pairs, they will return the same hash code. But I simply returned 0 because I have taken care whether two numbers are equal or not, two pairs are equal or not in the equals method, right? So I had to just ensure that whenever equals method is returning true, the hash code also returns true. Hash code also returns the same number. So what I did was, instead of doing complicated things, I made the hash code of all the quadruplets the same. The hash code of all the quadruplets the same. So hash code is never going to be a bottleneck for equals method to work. Okay, so this was just a small hack to ensure that our contains method and hash set uses this boolean equals method and should be able to compare when two pairs are same or not, right? And that's it. That's as simple as that, and this ensures that this set.contains method works. Okay, so now what you will do, you will find 4 pairs of number using these 4 nested loops, right? You will sum them up, right? And you are going to put that number into the hash set, and obviously you will put them into the hash set. If they do not contain, then you can add them, right? So this will include that there are no duplicates in this. Great. Now comes the interesting part. The interesting part is you will find, now you have found all the pairs of 4 numbers and what is their sum, right? And now you will simply just run across them and find what is the thing that you need, right? So over here I declare an iterator from the queue set, right? We didn't use a hash map because hash map basically needs 2 values, key to a value. We didn't needed that, we just needed the value. So I just created a simple set, and that's why queueset.iterator gives me the iterator of all the quadruplets present. Then I created the linked list of integers which I am supposed to return in the answer, right? I am supposed to return this list of integers. So I created that data structure, and while my iterator has next, I simply kept on adding the numbers into my linked list answer L, right? So over here I added all the numbers pairs which have the target 4, and then I converted that into a linked list. I converted that into a linked list by calling if while iter has next, keep converting them, create a linked list. In that linked list add the 4 numbers, and then add this complete linked list, this linked list which is a linked list of numbers, into the ans linked list, which is actually the linked list of integers. Okay, and then I simply returned answer. Okay, and we are done. This works perfectly well. Let me just explain to you once again in summary what we did. Okay, we found, using 4 nested loops, we found out all the pairs of numbers whose sum is target, right? And with the help of hash set, we were able to compare whether we are repeating on any kind of quadruplet, right? If any number, any pair of 4 numbers getting repeated or not, and if it is getting repeated, we exclude that, right? And if it is not repeating, we will simply add it to the hash set, and then we converted that hash set into a linked list over here, and then we return the linked list. The only catch here was about how do we get this hash set contains method working, and for that we had to do 3 things. One was creating the arrays sorted numbers, right? Second thing we had to do was create an equals method, and third thing we had to do was ensure the hash code for two quadruplets who will return equals return the same value. Okay, so this is it. And the time complexity of this is going to be n4 because we are going to create four pair of four numbers, and that's why it's going to be n to the power 4. So if you run this is going to work. Okay, great. So obviously this is not the best time complexity, right? So let me just introduce another method which is based on this, and had to show you this method for you to be able to understand the next method, because it is bit more next level thing, right? A more complicated thing, but it's going to be even more beautiful. Okay, so let me just copy that code for that, copy that code also for you, because this probably might make you fall in love with data structures if you understand the concept. But if you're just doing rote learning, then probably it will be a headache. Okay, so if that's the case, then you probably need to change your strategy. Learn for learning rather than memorizing. Okay, now this method is solution is also very similar to the solution that we did just now, but with a twist. Okay, and this you can probably think is a good way of probably improving the algorithm, right? Remember the two sum problem. What we did in that was we found all the numbers and put that into a hash set, right? And then we iterated each element from the hash set, and we found whether its corresponding target minus current number is present in the hash set or not, right? For example, let's say the target was equal to 100, right? So what we did was to take all the elements from the array and put them in the hash set, like 5, 7, 12, 15 and so on into the hash set, and then we iterated the array. Let's say we found the first number as 5, right? We know the target is 100, so what we will do is 100 minus 5 is 95, so we need to see whether 95 is present in the array, and with the help of the hash set we can find that in order 1 complexity, right? And because of that, our code in twosome can run in order and time complexity. Now, can we apply a similar kind of a thing over here? Yes, of course we can, right? The way to that is that instead of finding four pairs, we can reduce the problem to same as twosome by finding all the pair of two numbers or the couplets, right? All the pair of two numbers, all the couplets. So what I mean is, find all pairs of two numbers, and sum them. Okay, so as a result of this, you will get n square new numbers, right? And what do we want? We want what all pair of two numbers from these new numbers have sum equal to target. Okay, so let me give you an example on that. Let's say the numbers were 1, 6, 2, 9, 10, 3, 67. Okay, so and we have to find the pair of four numbers. So instead what we did, we converted this list of single numbers into a list of sum of two numbers, right? So we are going to do 1 plus 6, which is 7, 1 plus 2, which is 3, 1 plus 9, which is 10, 1 plus 10, which is 11, 1 plus 3, which is 4, 1 plus 76, which is 77, right? Next we are going to add 6 and 2, so we will get 8. We will do 6 and 9, so we will get 15, 6 and 10, 16, 6 and 3, 9, 6 and 76, 82. Similarly, we will find all pairs, right? And let's say the target was 15. So if we find pair of two numbers whose sum is 15 in this new array, we will be able to do so, right? So you can see that 11 plus 4 is 15, and then only thing you need is you need to find out how this 11 came, how this 4 came, and if there is no common number between them, then we have found the solution, right? So this is much better, seems to be much better improvement than the previous solution. Why? Because we have to find n square pairs, right? We take pair of two numbers from from an array of length n, so it will be done in a time complexity of n square, right? And now using the same hashed method as we use in toSum, we will be able to find in order one time how if there is a corresponding pair, right? Okay, so now let's see what the solution is, and it is going to be much more beautiful than the previous one. So this is the method that we are supposed to return. So here I created a hash map, right? And this hash map contains two things. One is the key. This key is the sum that we are looking for, right? The target was originally. Now we will use the sum of two pairs of numbers as key. And the second value is basically a linked list of all the pairs of numbers whose sum is this, right? For example, let's say the number is 5. So what will the linked list contain? This linked list might contain 1 comma 4, 2 comma 3, minus 1 comma 6, and so on. Basically all pairs of two numbers whose sum is 5. Okay, and now let's run this for loop and find all pair of two numbers whose sum is, let's find the sum of all pair of two numbers, right? So just like the previous one, where we are running two nested loops, we were doing 4 nested loops, we are going to now do 2 nested loops. So for int I equal to 0, I less than nums dot length minus 1, I plus plus, j will begin from I plus 1 to nums length, right? Again, why I am running it from 0 to nums length minus 1, so that when I reaches nums dot length minus 2, there is space for j even now, right? Because j is always going to begin from I plus 1. Okay, great. And inside this we will find int sum is equal to sum of nums of I common nums of j. You will sum them up and you will get that sum, and we will store that in the hash set, in the hash map. So we will say, does our hash map contains this key? Basically, have we come across any other pair of numbers whose sum is this? If it is, then we have to create a list. We have to add to the list, right? If these two numbers are there, what we are going to do? Okay, let's go other way around. If the hash map doesn't contain this sum, then we simply add that, right? So we will create a linked list, right? And in that linked list, we are going to create a couple and add that. Okay, this couple is similar to the quadruplet data structure we created previously. Quadruplet data structure had 4 numbers. In the couple data structure, we will have 2 numbers, right? So it basically represents, let's say, 4 comma 5, 9 comma 2, and so on. So because we come across the pairs nums I comma nums j, we are going to create a couple, new couple I comma j, right? And we will add that to the linked list, and then we will push this linked list in the hash map. Okay, but let's say if the hash map already contained that sum, so it would already be having a linked list stored, right? This hash map contains key as sum and value as linked list, right? So we will pass in the sum as key, we will retrieve that linked list of already existing numbers, and then in that linked list we will add the new couple I comma j, and then we'll put that linked list, the updated linked list, back in the hash map. Okay, and we will be done, right? We will be done. So what is going to be the time complexity in this one? The time complexity of running this is actually going to be this loop, including these two loops, they will make it n square, right? And inside this hash map, we are retrieving a linked list that will be done in order one time, right? Sorry, we are creating an element and we are doing an add operation. The add operation in this linked list, because we might be adding at the tail or might be adding at the head, so it will be only order one time. and then we are putting it in hash map, so it is going to be in order one time as an average, right? So because of this, the total time complexity of this is going to be order n square. Okay, so let me just explain to you again what we did. We ran two nested loops, and we find all the pairs of the numbers, found out their sum, and for a given sum, whatever pairs which correspond to this sum, we added that into a hash map. So hash map after the running of the two loops will look like this. The sum 10 is formed by 5 comma 5, 6 comma 4, 7 comma 3, right? The sum 3 is formed by 1 comma 2, 4 comma minus 1, and so on, right? So you will have the sum followed by the linked list of all the couples which form this, right? So a couple is nothing but a data structure of two numbers, and there will be certain more beautifications which will be introduced as we move across this video. Okay, so we have created the couple hash map hash set. Now we only need to do is, now what we are going to do is, now we are going to iterate the hash set, right? We are going to iterate the hash set for the pair of numbers, and we are going to see whether they are corresponding other pair of numbers such that they form a quadruplet whose sum is equal to target exists there or not, right? So this is a basically yeah, so we got the set of keys from the hash map, which is basically the set of all the values, and then we converted that, we got the iterator of that numbers from that, right? Because the key values are integers, so we created this, right? And then we created a hash set of quadruplets, right? Eventually in the answer we have to return a quadruplet, right? So that's why we are creating a hash set. Remember, in the previous algorithm, even there we had to create a hash set of quadruplets. Why did we have to create the hash set of quadruplets rather than a simple array or simple linked list? So that in order one time we can check whether the quadruplet that we have come across right now is same as or already exists in the hash set or not, in the existing list or not. That's why we are using hash set. Okay, so let's iterate across all sums, right? We got key sum is equal to I dot next, right? So we got the first sum, and then we found int needed is equal to target minus key sum, right? For example, if the target is 100 and we got the key sum as 20, we know that 100 minus 20 is equal to 80. So we have to find what pairs of numbers, what couples of number have the sum 80, right? So we will run this method. So if the hash map doesn't contains the needed number 80, we can move to the next loop of the iteration, and I simply wrote continue. But if it does contain, now comes the interesting part. Now if it does contain, we will have to do many things. One of the things is we will have to check. One of the thing is we already have, remember in the hash set of couples we have sum followed by the list of couples, right? So the key sum has a list of couples, and this needed value also has a list of couples, right? So how the pairs of number with sum 20 will be many, the pair of number with sum equal to 80 will be many, and we will have to match all of them together, and we will get all the pair of numbers whose sum is 100, right? That is one thing. Second thing you will have to check is, you will have to check whether a new quadruplet we are forming at any instant, does it already exist in the hash set of quadruplets. If it already exists, then we will have to skip it. If it doesn't, then we will add it to the hash set, right? So let's see how we are doing this. So linked list couple CL is equal to hm dot get keysum, right? So basically by passing the keysum value 20, we got the list of all couples whose sum is keysum, and similarly we got the linked list of all couples whose sum is equal to needed. So this is like matched list, and this is like current list. Okay, and now we are going to run a while loop and another while loop. What this is basically doing is, this is going to pair the couples together, for whichever we found a match, we are going to couple together and form a quadruplet, and we are going to check whether this quadruplet is already present in the hash set. If it is, we will skip that. If not, we will add it, right? So this is simply running an iterator. We got couple cc is equal to ci dot next, right? So we got the couple of numbers whose sum is equal to the key sum, right? And similarly, we will run another iterator for the match list, and we will say while mi has next, basically for all the couples whose sum we came across 80, let's iterate on that list, right? This was a list of 20, this was a list of 80, so this corresponds to the list of 20 and this one corresponds to the list of 80, right? So we got the first couple whose sum is 80. Now we check if cc dot equals mc continue. Now what does that mean? Okay, now there's a very subtle difference. In the couples, we are not storing the values stored inside the array, right? We are not storing nums I and nums j. No, we are only storing I and j. As you can see, I stored only I and j. This is very, very crucial, right? So that's why over here it is possible that, for example, let's say our target was 18, right? So let's say the cc is 4, corresponds to index, corresponds to the numbers 4, corresponds to the numbers present at index x and y whose values are 4 and 5. The number at x is 4, the number at y is 5, so their sum is 9, right? Let's say mc corresponds to the other side, y comma x, where y corresponds to 5 and x corresponds to 4. Now this couple is same as actually the basically xy and yx corresponds to the same numbers, right? But their sum is going to be 18. But that's not a real quadruplet because the same indexes are coming 2 times, right? So this match is very, very important that we check no index is common between the first couple and the second couple. When I took xy and yx, both the indexes were same, but there's another possibility. Another possibility is that the first couple may have index x comma y, the second couple might have z comma x, right? X comma y and z comma x. The xth index is coming twice, right? But because of that, we cannot take the x index 2 times. We actually need 4. That's why we would have to define this equals method, right? Couples method, the equals method of couple, and this is going to be very similar to the quadruplet, and that's why I first introduced you to that method so that you can understand the value of equals method, and now you can understand what equals method does in couples. Okay, so let's just check. So I created a class couple which is basically int x, int y, and they're created, and I created an equals method, right? And along with the equals method, I had to create a hash code which is returning 0. Okay, that you probably already understood from the quadruplet code. If not, please watch the video again, maybe 2 to 3 times, and try to understand this deep concept because this is a very beautiful piece of code, right? So here we come, couple O is equal to couple other. Very good. Now comes a very interesting part. Boolean equal is equal to whether is equal to or. See over here we have or condition. It's or of 4. If you see the code of quadruplet, there was an and between 4 conditions, right? There was an and. But if you see in couple, there's an or, which basically says that the first number of the first couple is equal to the first number of the other couple, right? And the first number of the first couple is equal to second number of the second couple. So this should not be the case, right? That's why we have put an or. We didn't put an and, but we didn't put an or. This is basically saying, let's say the first pair has x comma y, the second one has a comma b, then x is not equal to a, x is not equal to b. Then this one says y is not equal to a and y is not equal to b, right? So x cannot be equal to a or b, nor y can be equal to a or b. Even if one of them are equal, then we have a clash, and then equals must return true. That's why I put an or condition over here, right? Because if even one of them equal, then if you combine the two couples together, they won't form four numbers. They will only form maybe two numbers or three numbers, right? Because of repetition. That's why the equals method had to be different. Probably if you didn't understand, try to pause the video, watch it again, maybe come to it another couple of hours later, maybe a couple of days later, but make sure you understand this because this is very, very interesting. Okay, so if cc dot equals, then continue, right? Basically, if all the four indices are not different, then continue. Now this another important concept, that I use indices instead of the nums I and nums j. Why? Because a number can repeat, right? Like for example 5555, if they are present at four different indices, that's all right, that is all right. But the same 5 occurring in the same index must not repeat. That's why I saved in the couple I comma j the indices. Okay, so if any of them matches, skip the couples, right? But if the four indices are different, form a quadruplet, right? You take the four numbers cc dot first, cc dot second, mc dot first, mc dot second, you get the four numbers, and using our original quadruplet method, create the four numbers and sort them, and we already know how the equals method work in that, right? So create that and then check whether our q set of quadruplets contain the current quadruplet. If it contains, we can skip. If it doesn't contain, we can simply add it, right? And in this equals or contains method, we will have to use an and, because we don't want all the pairs to be same in that, right? All the four numbers to be same in that, because repetition is not allowed, right? Repetition of values is not allowed. That's why in the quadruplet we had to save, in the quadruplet we have to store the nums in the value stored inside the nums, while inside the couple we had to store the indices. We have to store the values inside this, because the values are not allowed to be repeated in the quadruplet. Sorry, not in the quadruplet, in the answer. No quadruplet should repeat, and that's what you have to return, right? So you will get q set dot contains this and done, right? So till here this was the only different part. After this, the part is very simple, where you have to convert the set of quadruplets obtained into a linked list and simply return the answer. Okay, so I'm going to run this code. This code will actually take greater time than that, but let's see the time and space complexity for ourselves and try and analyze things. If you think the time and space complexity of this is different from what I analyze, feel free to chip in and explain. Okay, I'm leaving that thing opened up to you, but I'm telling you the time and space complexity which I am sharing. Okay, so this is our method, right? This is our main method. Inside this we have two for loops which are running from I to, this first loop is running n time, the second one will be running n minus 1, then this one will run n minus 2, and so on, right? So basically you can say the product will be n square, and each of this operation is order 1. So this, because of this, the total time complexity will be order n square for finding all the n square pairs, right? Now the interesting part is that this while function, while I has next, key is equal to this is equal to this is going to run n square times. Okay, because this is going to run for all the numbers which are present in the hash set of the couples, right? It's going to run the hash set of couple, and the number of couples are n square. So because of this is going to run n square times, and we are going to find for that what is the needed one, right? And then we, in order one time, we will be able to find whether there is a match with this or there's no match with this, right? And only when there is a match, this part of the code will run, right? So these two nested whiles will only run only when we have found a match. Okay, so because of this, you can say that this entire 3 while loop will not actually run for order n cube time, but for order max of order n square, comma, order number of answers, number of answer pairs. So how many answer pairs are going to be there in the solution, that much time this is going to run, right? So the time complexity of this is probably, because of that, much better than order n4. It might actually be order n square. Okay, and space complexity is going to be order n square, because we are going to save n square, we're going to save n square couples in the headset. Okay, so I hope you learned a lot. I understand that this was a new concept for you. Probably this will make data structures more interesting, or maybe push you a little bit away. But once you start getting the hang of it, once you start falling in love with it, you will understand the power of going deep. And this passion, or this interest, or this ability to see things deeply, or ability to understand things from new point of view, is going to what make the interviews interesting for the interviewer, and make them realize how intelligent or how good a problem solver you are, right? So always remember to go dive deep, understand. Always remember there are a lot of things to understand, and what I'm giving over here is just the surface. If I had to explain one question, explain everything, it might actually take 5 to 10 hours understanding all the small bits. That's why I encourage each one of you to first focus on the basics, probably join in the courses which are there, and master those concepts, learn those basic success formula, and apply that, so that you can crack those interviews, earn a package of 12 to 30 lakhs INR per annum in India, or 100 to 200k USD outside, maybe in US. Okay, so thanks for watching. Keep liking, keep commenting, keep subscribing. Drop in the comments below what you loved about the video, what you understood, what are the new things that you understand, what are the things that you want me to cover more in the next video, and what you want me to continue to share, right? Because only when you're going to comment and share with me the part that you love, the part that you find more interesting, would I understand that this is what is needed, I will be creating that more, right? So I want you to right now click on the like button. I want you to right now click on the subscribe button if you have not, and comment below what you learned. Okay, and don't forget to click on the link and join the group, join the course for the learning the practice of data structures and algorithms. Happy learning. Bye bye. Take care.